Welcome back, Laker Gang. Last section in 9.2, we learned how to plot points on a coordinate grid and how to interpret that, how to write down ordered pairs. What we're going to be doing now is we're going to be using that information to transfer data from a graph, from a problem, from a situation into a coordinate grid. And this is really helpful because it lets us see data. It lets us see trends. It helps us predict what's going to happen in the future. Helps us decide what happened in between those times that we measured. So in this first experiment here, we are using a cup of water, room temperature water, I might add. We're tossing some ice cubes, some frozen boys into that cup, and we are seeing what happens to the temperature over time. Obviously, it's going to get colder, but how does it get colder? Does it just get colder by a certain amount every second? Does it change over time? Does it get really cold really quick and then warm up? What happens? That's what we're going to be doing. So, here is a quick little version of me doing this experiment so you don't have to.
Hey everybody, here is our little math experiment. First, we get some room temperature water. Ooh, that room temp. Perfect, flawless, beautiful. Add just a couple of ice cubes. So, maybe one more. And now, of course, we take the temperature and we record every 10 seconds. Thanks for watching.
Alright, and hopefully you enjoyed that. Again, you don't have to do the experiment, you can just steal my data. So we've got 68 at 0 seconds, because that's the temperature of the water before we actually got started. After 10 seconds, 59, 53, 47, you get the drift. I'm just going to write them down without having to talk, my word. 44, 41, I can't stop talking, please send help. 38. Okay, so now that we've done this, it's pretty simple what we have to do. We change all of these numbers into ordered pairs. So our x-axis would be our time, and our y-axis would be our temperature, even though that looks like an x. My gosh, I'm awful. So if we look at these questions, number one, why would you record the beginning temperature at 0 seconds? Well, you want to know what temperature the water's at before you actually start. Number two, describe what happens to the temperature of the water in 60 seconds during the experiment. So, if we look at these numbers, 68 to 59, that's 9 degrees different in just 10 seconds. So that's pretty quick. 10 to 20, 6 degrees difference. Another 6 degrees difference at 20 to 30. But then we realize something. It kind of calms down a little bit. It doesn't go down as quickly. Sure, the temperature's still going down, but it definitely slows up. So if we were going to describe what happens to the temperature of the water, when you first put those ice cubes in, the water gets much colder much faster. However, after you get past 30 seconds or 40 seconds, the temperature really doesn't go down as fast. It still goes down, but not as quickly. And analyze your observations of the temperature of water. Explain what you think would happen if it continued for another 60 seconds. Well, eventually, it would just stop getting colder, either because the ice would fully melt or the temperature would just get to as close to the freezing point as it could, but the water wouldn't freeze, so it would just kind of stay there. So now for the big part. Let's take this information and turn it into a graph. So as you can see, our y-axis goes up by 5 every single time. And that's what you have to do. Whenever you have your x-axis and your y-axis, you want it to be consistent. You want the number to go up by the same amount every time. It just doesn't always help us because we have numbers like 68. That's not a multiple of 5. So just put it as close as you can. We know it would be in between 70 and 65. So let's put it right up there for 0, 68. Then we have 10, 59. Just throw that right below 60. 2053. Right there. 3047. Right there. 4044. 5041. 6038. And now for the most fun part of all, we connect the dots. And if you notice, it's pretty steep at first. It goes down by a whole lot, kind of like we said, but as the time goes on, it starts to get slower and slower. And we can use that to kind of predict what would eventually happen, because that line would continue. You would keep going down maybe a little bit, and then eventually it would just stop. It would quit getting colder altogether, and it would just stay about the same point, maybe even rise up to reach room temperature. Alright, so now for this one, we're doing the exact same thing. We're taking these points, which we already know what they mean. We already know which number represents the axis. If we look down here, x-axis is age, y-axis is height. So throw an x by your age and a y by your height. That way you don't get confused. So write the ordered pairs for each point. That's not going to be too bad. In order to write our orders pairs for each point, we just take that x-coordinate and that y-coordinate. So I'm going to pause the video right here, and then what you can do, just continue once you've written it down to make sure you got it all the same. After you do your points, go ahead and graph them as well. Hopefully you are seeing something like this. Now we can go through these questions. Number 2, what does the ordered pair 338 tell you about his height and age? So 3 is going to refer to his age. So whenever he was 3 years old, he was how tall? Well, we look at the chart. We see 32, or excuse me, we see 3, and we go up. Looks like he was about 38 inches tall. So now we can look at number 3. Why would the point 642 be nonsense? Well, let's think about it. If we were to graph that point, it would be right here. You'll notice something kind of weird about that. And to do that, you have to realize what it is we're graphing exactly. Well, we're graphing his height, and his height at certain age. So whenever he was 5, he was 44 inches tall. So would it really make sense for him to be 42 inches tall whenever he was 6? No, it would not. Sometimes your charts will go up and down like that, but probably not whenever we're measuring your age. Sure, once you get older, you may hunch over and you may lose a couple inches or something like that. Probably not going to be happening when we're 5, unless Ryan looks a little something like this. Hopefully he does not, but there's no pictures, so I guess we never know. Moving on. Let's see how you all do with plotting this information about the Dakota River. So go ahead and plot that information, and then I will check it with you. So go ahead and pause the video and plot. Alright, so hopefully your plot looks something like this. Now, as you can see, we had some points such as 15 and 7 that did not appear on our Y. But we know that 7 is in between 6 and 8, and we know that 15 is in between 14 and 16. So we know exactly where to put that. Same thing up here. I know I didn't really mention it, but every one of these points goes up by 10 on the Y-axis. So that means they're skipping 2 lines to make it 10. If you just skip 1 line, it's going to go up by half that much. So 5. Sorry for not pointing that out earlier, gang. So on and so forth. It's just not necessary to mention it. Alright, so I'm sure you all did great with that. So now let's take a look at number 5. Mary. Mary, Mary, Mary. What a goon! Mary places a miniature car onto a track with launchers. The speed of the car is recorded every foot. However, she has made a very critical mistake in her graph. So here's what I'll advise you to do. Go ahead and graph the data yourself. Use this information up here, graph it yourself, and then see if you can't figure out what it is she did wrong. And then we will kind of talk about that, as well as questions 6 and 7. So go ahead, gang, pause it now. Gang, so hopefully your map looks your graph looks something like this. And it makes sense if you think about it. Our distance is our x coordinate. My pen's not working. Our x coordinate, our speed is our y coordinate. So at 0 distance, as in when the car is not moved at all, it has no speed in miles per hour. But at 1 foot, it's going 4 miles per hour. At 2 feet, it's going 8 miles per hour. And if you think about it, when you first launch that car, or if you were to toss a car, it's going to speed up very, very quickly. And then finally, it'll get to a point, looks like that is point number 2 for us, where it's not going to go any faster. And then because of friction and other things, it's eventually going to slow down and then stop, as you can see by my modeling of the experiment here.
Car launcher, go! Well, that was kind of... Oh my!
Alright, so hopefully you enjoyed that. So let's take a look. Let's try and figure out what mistake Mary made, because Mary is a goonish little goblin. She has what looks to be our map, or our graph, but sideways. And that is because she mixed up her x and y coordinates. Instead of 1, 4, like what we have here, she marked it at 4, 1. And so on and so forth. So her graph is completely backwards. But let's take a look at number 7. At what distance do you think the car will stop? Well, if we keep following this trend, and if we think about it, we know it's going to. Let's guess at 5. If we keep going down, it looks like at 5, probably not. 5, it'll probably be going somewhere around a little bit less than 2 miles per hour. And then at 6 is when it should hit 0. So that ordered pair would be, make sure you do x before y, 6, comma, 0. Alright, guys and girls, thanks so much for watching. If you have any questions, just throw them in the comment below. Email me, dojo me, do whatever you like. But good luck on this section. Good luck on your homework. And as always, stay safe. I miss you all. Nunley out.